Welcome back. This is part 2 of our look at this ZX Spectrum. Last time we got it to the point where it at least powers on, although it was doing some rather funky stuff on the screen, displaying lots of corruption. So let's get stuck in again and see if we can't get it sorted. Let's start with the typical test. We're going to use the oscilloscope, and on the CPU I want to check out the reset, the clock, the data lines and the address lines, just to make sure everything looks right. This big heatsink here though, coming off the 7805 regulator, this is in the way, so we need to move that. But we can't disconnect it completely because I need the board running. This regulator generates an awful lot of heat, so it needs the heatsink on it to stop it overheating and dying. Now we do need to hook up a ground, but one thing you need to be super careful of, if you'll notice on the top side here, all the traces are silver. That's because there's no solder mask. There is on the bottom side, but not on the top side. Yet another cost saving measure, but it is really easy to short something out. The ground side of that, I think we should be able to clip onto without causing too many problems. And then if we pull up the schematic for the Spectrum and just take a look around the CPU, we can see there on pin 26 we have the reset line, so let's check that first. The line over the top of the word reset means that it's active low. So what we should see when we initially turn the machine on, we should see that low and then it will jump up to high. This is a 40 pin package, so 1 to 20 on that side. And starting on this side we have 21, 22, 23, 24, 25, 26. That should be the reset there. And if I just switch the power on, well, you can see there that it does slowly rise. Let's just try that again. Yeah, so that seems okay. It starts off low and then makes its way high, bringing the chip out of reset. So the other thing that the system needs is a clock. That will be on pin 6. Now this scope isn't very good at looking at clock signals above a couple of megahertz, and it seems here that our frequency is sitting at about 3.5 megahertz. It is jumping all over the place there, but that is just this scope. The Spectrum runs at a clock of 3.5, so I dare say that is fine. So let's take a look at the data lines. Those are on pins 7 through 15. Skipping out pin 11 though, which is just VCC, 5 volts into the chip. So pin 7 first. That looks a bit funny, doesn't it? Pin 8. Likewise, that doesn't really look right. Pin 9. That definitely doesn't look right. 10. 11, that's just 5 volts. 12. 13. 14. 15. So yeah, all the data lines definitely do not look right. Now the assumption last time with the failed TR4 transistor, well, we thought that one or maybe even all of these lower RAM chips could be bad. And if you take a look on the schematic around these chips, well, 8-bit computer, so 8 data lines, and there's 8 of these chips. Each one of these sits on 1 bit of that data line independently, and considering all 8 of them on the CPU looked a bit screwed up, I'm wondering, do we have 8 dead chips here? Now there is other stuff on the data bus, you know, the upper memory sits on it as well, as does the ROM, and of course the ULA. You know, you can't get a diagnostic test for this machine, a diagnostic cartridge, or you can even just get a diagnostic ROM. One of those would be really handy. Remove the upper RAM, that's them sitting there, and I pulled out sockets to put in their place. But we don't need anything fitted there. The system should power on, or well, what I want to see anyway is, does it make any difference when we do power it on? Do we see anything different on the screen? So no, we still have the same mess on screen, but that's fine. That's sort of what I was expecting, to be honest. But at least in doing this, in removing those upper RAM chips, we've removed one thing from that data bus, and we've confirmed that the fault is not within that. Next thing I want to do then is just remove all of these chips. So the lower RAM is out. That's it sitting there in the order in which it came out, and I fitted these sockets instead. Now what I want to try and do is let's power the machine on with no RAM. So you can see it gives us a couple of coloured bars and then a lot of static in between that. Now the Spectrum uses its lower 16K to draw the screen. So what I want to try is install one of these at a time. I'll just stick them into this first socket here. I just want to go through them all to see if any of them make any difference to what is displayed. And my theory being, if any of them do, that'll be a good RAM chip. If any of them don't make any difference or make it worse, that might be a bad chip. So first one in there, and that looks more or less exactly the same to me. I'm just going to go through all of these, see if any of them make it any different. So far those 6 haven't made any difference, but this 7th one, as you can see now, we are just getting the coloured bars, the sort of static in between. Well, there is a little bit of it, but it's mostly away. Would that suggest that that chip is good and all those ones are bad? Obviously we're not going to get a proper image because all the rest of them are missing, but that's my theory anyway. So far we only have one good memory chip. Then what about the last one? And yeah, it just does the same as all the rest. So if my theory is correct, we have one good chip and 7 bad. I suppose at this rate I may as well just order a full set, all 8 of them. I'm still waiting for the new chips to arrive. I was actually just on the computer doing a bit of editing of the video that you've seen up to now, and it sort of dawned on me that while I did my little test with these memory chips, I probably should have had a look at the data line again with the scope to see if there was any difference. So I was just having a bit of a poke about with this, and I noticed something. Our voltages are all screwed up again, because if I just power the board up, and on these memory sockets, as we know, pin 16, that is ground, and pin 1, this is meant to be -5, but as you can see, it is negative nothing. Equally, 8 down here, that's meant to be +12, and it's only sitting at 9.7, 9.8. 5 volts good though, it's on pin 9. So something is screwed up again. I have no idea when this happened, because as you've seen at the end of the last video, those voltages were good. I suppose the suspect again is going to be this transistor, TR4. Has that blew up again? If it has, why did it? I'm going to pull that out and test it. Right, that's it out, and I have the meter here on its diode test. So being an NPN transistor, we put the red lead onto the center pin, and then to each of the outer pins with the black lead we should be seeing about 700 ohms, 700-800 thereabouts. And yeah, okay, there's 700 there. What about the other one? 200 odd? That's way too low. I think this has failed again. Why has it failed? If we swap them over, put the black probe onto the center pin, we shouldn't get anything. And on that side, as you can see, there's nothing. And on that side, there's that 200 odd again. So this transistor has definitely failed. But why? Could one of those RAM chips being faulty, or several of those chips being faulty, could that lead to excessive current being drawn through this thing and cause it to blow up? I tell you what though, it is just as well I caught it now before the new chips arrived and I fitted them, because with those voltages screwed up, if I had to put the new chips in there, they probably would have got fried straight away. Okay, put another new transistor in there, just the same one again, the 8050, and only because I don't have anything else. Well, let's just power up the board and check those voltages. Yeah, so -5 more or less, and +12. All the other components related to the voltage regulation, they all seem okay. So the only guess I have here really is that one of these chips must be screwed up enough to the point where it's drawing so much current that it blows up our transistor. So yeah, I have been over the board and I can't find anything wrong. I can't find any shorts. Hooked up the bench power supply here and we have it limited to 750 milliamp with all those memory chips installed. If I turn this on, well, you can see it has settled there at 0.666 of an amp, but that is pretty typical. So it's not like it's drawing excessive current and something in here is shorted, causing TR4 to blow up. Maybe it was just a crap transistor. Maybe a box of 250 transistors from Amazon for about £10 isn't as good of a deal as it initially sounded. But it's working again for now. And we have our -5 and 12 volts. Of course, if these chips weren't damaged before, well, they most definitely are now, because they all have been powered on several times with those voltages screwed up. I just didn't know that had happened. So, as for the reason that I was coming out here to have another look at this board, despite the fact that the new memory chips have not arrived, well, most of everything that you'd seen up to that point, I had actually recorded it before the first video in this series went out. But one of the comments on that video was, why don't you make your own diagnostic ROM? And well, that's not a bad idea. I just so happen to have some blank ROMs here in stock. So let's have a go at doing that. There are two diagnostic ROMs available for the ZX Spectrum, but it is this one that I am going to use, created by Brendan Alford. It's available on GitHub and I will link this in the video's description. We can grab it here under firmware, and if we scroll down to this release package, we're looking for the file testrom.bin. It's that one there. Now you'll notice this is a 16K file, and that's because the ROM on the ZX Spectrum, it's 16K, but the ROM chips that I have, those are actually 64K chips, although that's not a big problem. We can easily turn this into a 64K ROM just by quadrupling the contents of it. So if we load a command prompt and navigate to that folder, there's our testrom.bin, and all we need to do is run this command. So copy testrom.bin, need to tell it that it's a binary, and we're going to add that to testrom.bin, add it again to testrom.bin. We'll have one more of those, and let's save it as a file, 64K testrom.bin, and that too will be a binary. And you can see here that is our new 64K ROM created. So effectively all we are doing here is filling the full 64K of the chip with 4 copies of the same ROM image. It would be possible to put 4 different ROM images on there, and then by manipulating address lines 14 and 15 on the ROM chip, either putting them high or low, you could essentially tell the Spectrum to load any one of your 4 images that you could put in here. I'm not going to bother with that today though. It's maybe something I might look at some point in the future, but for now I just want to try and run the diagnostic. So we need to load our software for the EEPROM burner. We can select our chip. That's my ones there. 28 pin dip package by ST. The last ROMs I was burning was the custom kickstarts for the Amiga. We can load our new ROM image and I can just proceed to write it. In fact, before we do that, let's just double check that that did copy that through 4 times into this image. So the first 16K would be from address 0000 to 4000. And there's where it should start again. And it does seem to. So when it gets down to 4070 there, you can see ZX diagnostic. Let's just go back to the start. So 070. Yep. That's exactly the same. Our little copy procedure worked. Right, let me write this. But just before we install it in the Spectrum, there are a couple of other things that we have to modify. So there's our ROM ready to go. We are going to fit this socket here in place of that original ROM. But the other thing that we need to modify, down here on the board, there are 2 little jumper links. And if we just take a quick look at this guide from the Retro LM website. Now, this guide was written for the 27C256 chip, as you can see, which is the 32K variant. We're using the 512 or the 64K variant of the ROM. Under step 1, it's telling us to put a link between pins 28 and pin 1. On this chip, pin 1 is address line 15, so we don't really need to do that. All that we'll be doing is pulling that pin high. Although I suppose we need to do something with it, because on the original ROM here it would just be floating. So let's just put that link in, shall we? But I'm not going to do it on the underside, as the image shows. I'm going to do it on the actual chip itself. Just because when we're done with this, I want to put the original ROM chip back in. Under step 2, we need to remove those 2 links. And then under step 3, as you can see, we need to fit a couple of diodes and a little resistor. The reason that we have these links here anyway, is because when these machines were built, there were 2 different ROM chips that Sinclair would use. Those 2 chips had a slightly different pinout, and basically these links here are just altering that pinout dependent on whatever version of the ROM is used. But by putting in the little mod with the diodes, basically just means we can use whatever ROM chip we want. So I'm going to do all that, then we'll get the chip in and run the diagnostic to see if that tells us if indeed it is just our faulty memory, or if it picks up anything else that might be broken. So despite using the desoldering station, the chip doesn't want to come, and I don't want to try and force it, just in case I break any of the little vias. So I'm just going to hit it with a little bit of hot air, and that should free up any of the remaining solder, and the chip should just drop out. There we are. One chip removed with no damage. Just give this a bit of a quick clean. Then I'll just fit the new socket with the notch towards the top. All done and ready to test. As it's set up here, we're taking 5 volt or logic high to address line 15 via this jumper wire here, and also address line 14 via this little patch wire here. So within our ROM, it is that last 16K bank that we are accessing. If you wanted to modify this to be able to access any of those 4 16K banks, well, you'd need to break that and that, put a switch in line with them, then you could switch it between 5 volts and ground. But as I said, I just want to test the diagnostic, so let's hook it up and let's see what it does. Well, need to figure out how the diagnostic actually works first. So let's take another quick look at this GitHub. How to use Plug in the device containing the diagnostic firmware and power on the machine while our ROM is in there. You should hear 8 short beeps, followed by 2 distinct tones, and see a blue then green border if the display is active. This confirms that the machine is running, at least the CPU and ULA are working, and there are no issues with the address or data bus on the machine under test that prevent code execution. If running with a diagnostic board, well, we're not, we're just using the ROM, so we can ignore that. If the display is active, you should see a line of text in the middle briefly. Well, the Spectrum needs its lower 16K here to display anything on the screen, so given the fact that our voltages were all screwed up, I don't think we are going to see very much here. I'm expecting all of those to be fried. But this goes on to say that the firmware will then execute some memory tests on the lower 16K as described below. So, lower RAM testing. As the lower RAM of the Spectrum is used for display, we cannot assume that the machine can produce a correct display nor rely on it for output. Therefore, the lower RAM testing will produce some test patterns on the display that exercise the RAM in various ways, and if a failure is found, we'll report the result by way of a series of stripes in the border, presumably these things. There will be 8 stripes representing bits 0 through 7. That corresponds to the memory ICs. Green stripe indicates healthy, red one indicates a fault. So, let's see what our Spectrum is doing. Well, there's our blue border, followed by green, which went red straight away. And check that out, 8 red stripes. Looks like we have 8 dead memory chips. Notice there was no tones out of the speaker. So do we have another fault down here somewhere? Maybe that transistor is blowing as well, TR7. I think that's something to do with the speaker. But the diagnostic test runs. So I think we could take it that at least our CPU is good. And hopefully our ULA is good. It obviously can't get too far because it has no good memory chips to continue with. And since I am still waiting on the new chips to arrive, well, I don't think there's much point in doing anything further until we get those. So now it's just the waiting game.
No, the waiting game sucks. Let's play Hungry Hungry Hippos.
Or instead of Hungry Hungry Hippos, let's figure out why there's no sound coming out of this thing. The main suspect has to be transistor TR7. So let's pull that out and test it. Okay, so another NPN transistor. And yeah, another bad one. Now this is a ZTX450. And I don't have any direct replacements, but going to our excellent little box of questionable transistors, well, I can use one of these, a BC337. It is more or less exactly the same specification, just the output current for this is rated slightly lower. That one's rated at 1 amp, this is 800 milliamp. Honestly though, I cannot see this getting anywhere near that sort of number, so this should be fine. Right, let's listen for some sounds. And no, it's seemingly doing nothing. Looking at the schematic, the next thing really would be diode D9. It sits there just above that transistor. And it seems as if that diode is shorted. So let me get that replaced, and hopefully that will restore some sound. New diode in there, and I just replaced that transistor again, because no doubt the other one got damaged with the diode being shorted. So hopefully this time it makes a noise. And no, it doesn't. Why does this Spectrum not like me? Maybe if I had paid closer attention to the schematic. It tells us there that we should get a reading of 40 ohms across the speaker. And as you can see, our speaker is more or less a dead short. So, along with the transistor and the diode, the speaker itself has also blown. Now, I don't have another one of these, but what I do have is an old PC speaker. This thing only reads about 16 ohms across it though. So I'm just going to put a 22 ohm resistor in line with it as well, and that'll bring us up to more or less the 40 ohms that the spec is looking for. Right, come on, this is bound to work. We're going to get sounds out of it this time. Yep. Well, yes, it is making noises. It's just incredibly quiet. I guess I'll just have to order the proper speaker for it. But if I leave my microphone sitting beside it there, hopefully you could hear that a bit clearer. And at least we have some semblance of sound once again. Well, we are a couple of days later and we have some chips. So let's get those out. We'll get 8 of these in. I actually bought this set of 10 for 116s. So we'll put 8 of them in there, power it up, and you never know, it might magically work. I've also fitted sockets here so that we can put the upper memory back in as well. But in the first instance, let's just get the new lower RAM into here. And these are brand new chips, new old stock. Or well, they were certainly listed like that anyway. They do look new. Nice long legs on them. Just need to bend those legs in ever so slightly. And yes, I know you can't get a proper tool to do that, but I don't have one. Right, here we go. The moment of truth. Please work. Now what? Those 2 chips there control the lower RAM. SN74LS157N. Well, we just pull those and test them. Have to admit, I am feeling a little bit deflated there. I genuinely thought we were going to see some life. But why would anything be simple? Especially with this little spectrum. So the logic chips are out, and I fitted 2 sockets here in their place. I do have new ones that we could just fit here and see what happens, but let's test these. And we can use our TL866 to do that. So within the XG Pro software, this is really simple. All you got to do is to go into select IC. It's a logic IC 74157. Select that and test. It will be absolutely hilarious if the problem here the whole time has just been these 2 chips, because I always had spares of these. That would just be typical. Let's test the other one. And it's faulty too. Unbelievable. There's the 2 new chips there. If we put one of those into our tester, and as you can see, that passes fine. So let's put those 2 in there. Makes me wonder if those other 4 chips, if they'll work. Those 2 there are the same part number as those. That one's a 7400, that one is a 7432. Problem being, of course, I only have one more, 74157. So hopefully this problem is limited to just those 2. And I'm just realizing that I had taken that heatsink off. Let's put that back on. I had taken that off when soldering on these sockets here, just because this was flopping about a bit, and then just forgot about it. So let's hook up some power. Composite. And obviously now it's just going to work. So there you are, we have just learnt something, and perhaps if I had read that GitHub for this test ROM a bit better, maybe it would have pointed this out to us. But when it powered on there, the border went blue, then green, but stayed green. Previously it went blue, then green, then immediately red. You can see now that it has gone red. That's because it's trying to test the upper RAM, which isn't installed. So that is indicating a fault. And when it went red initially, you know, when it went blue, then green, red straight away, that was telling us that we had a problem here. Well, live and learn. It is my first Spectrum after all, but we will know that for the future. Of course, what we're going to have to do now is get that upper memory back in and see if all those fields turn into a pass. Well, there we are. Failures. And it is suggesting that we check these. 4 chips out. 2 of them are good and 2 of them are bad. Well, 7432. That's good. 74157. That's bad. 7400. That's good. And unfortunately 74157, well, that's bad. But I did find another one. So there's one there, that's good. New old stock, that can go in there. And I also found this one, which is also good, but it was missing a leg. Now I have soldered a leg onto it at that point. I'm not sure how well it will last though. I mean, it's on there, but it may break at some point, as on the leg, may break off. Need to be careful putting it in here. Yeah, seemed to go in okay. So let's run our test again. Are we finally going to get a clean bill of health for our Spectrum? I've made a mistake here. The 2 sockets I have put in that position are 2 pins too big. That was silly. I'll have to replace them at some point. But for now, I think the correct orientation will be to put the chips in that way. Right, come on. This is going to work. We are going to get a clean bill of health for our Spectrum. Right, all looking good so far. Well, so much for that idea. I'm just going to try swapping those 2 out anyway. I know they do work, but they're not making great contact in those sockets. And no, we still have 4 fails. All it's really pointing to now is these chips being bad. I have spent more time screwing around with this than I would care to admit. Got the scope out again. Now I was just going over the 2 157s, checking the address lines. And I noticed that a few of the pins were actually floating, which seemed odd. Well, seemed odd until I turned this upside down. Can anyone spot the problem? I dare say there's a better chance of this working if all the pins were soldered. Missed out one entire row. One side of one chip. How did I even do that? The only thing I can possibly blame that on is working late into the night. When I put those sockets on, it was after midnight. I was rather tired and obviously just completely missed one side of it. Not that that is much of an excuse. Let's see if it works now. And no, still problems. Although, look at that. 48 tests failed. Failure found in bits, bit 0 and bit 5. Like the lower RAM, each chip on the upper RAM represents 1 bit on the data bus. So looking at the schematic, I would think IC15 is probably bit 0 and IC20 would be bit 5. So that one. And that one. We can't confirm that, of course. Let's take that one, put it in there. We can take that one, put it in there. And let's see if our fault moves to bits 1 and 2. And check it out, it does. So failure found in bits 1 and 2. Those two chips must be bad. These are 4164 memory chips. I'm not sure if I have any though. I'll have a look. Found 2 chips, so let's just get them in. And surely this now has to be one fully working Spectrum. Pass. 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 Come on. Oh yes. Upper RAM passed. Our Spectrum's looking good. Testing completed. One Spectrum fixed. Let's put the original ROM back in and see if it boots. No. Is that ROM chip bad? I suppose I can just burn another ROM image. Okay, I have wrote the ROM image onto this one. I have a few of these chips, so I don't mind using them for this purpose. Right, come on. Boot. And there it is. 1982 Sinclair Research Limited. Let's just put it all back in the case. I suppose we should test the keyboard. Q. Oh, there it is. That's okay. It seemingly all works fine. Quick reset, and let's see if I can make it do something. Let's just go for the Hello World. All these shortcuts take a bit of getting used to, although it is handy. I cannot deny that. Because I didn't have to type in print, just press the button. Didn't have to type in go to. Don't even have to type in run. I actually quite like that. That's really clever. And yeah, working fine. Well, that's it. One ZX Spectrum up and running. It still needs a new cover for the keyboard here, and it needs some feet. Also needs that speaker, because the one I fitted in there is far too quiet. So yes, still a few bits and pieces to do, but for this video, it's definitely long enough, and I'm just happy to say that the Spectrum is fixed. It works. The cosmetics I can come back to at some point in the future. I do need to try loading a couple of games on it, and I do have some tapes, but I'll have to get a tape deck to do that with. Or if anyone knows of any modern solutions for loading games onto the ZX Spectrum, please let me know, and it's something I could always look into. But that is it for this video. So hopefully you enjoyed what you've seen. If you did, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.